Section 1.5 is the beginning of calculus, and we start with this idea of a limit. The idea of a limit is you getting very close to a number but never reach. Just to demonstrate an idea of how things work, I take a spring and attach the weight to it, and I pull it down, right? And I notice every time I reach, the stretch reaches 10 centimeters, the spring breaks. So I want to know how far can I go before 10 centimeters and the spring doesn't break. Do I go to 0.9? Do I go to do I go to 9? Do I go to 9? Do I go to 9.5? Do I go to 9.9? That's the idea of a limit. And this is what it says. The definition of a limit, for us it's going to be straightforward, even though this is a very annoying idea in calculus. For us, we're going to use it in one direction. If y, there's y, becomes very close to a number as x approaches a value, in this case as x approaches 10, so x will be 9, 9.95, 9.99, 9.999, right? What is y doing? Y is the stiffness of the spring in this case. In this problem right here, this is y all the time. We're trying to figure out what is x squared minus 4x minus 1 approaching as x reaches 1. We're never going to get to 1, but we're going to get very close to 1, and this is how we write it. We say the limit as a limit of f of x, of whatever it is you're measuring, as x approaches c is L. Well, let's play with this, and let me put this on a number line so we could figure it out. Now we need to use a calculator. I'm going to show you how to use it. Remember here, we're looking for the limit as x approaches 1. So this is what we do. We pick 0.9. Do you notice if this is 0, this is 1, and this is 2? 0.9 is about, let's say, right there. So give me a number close to 1, not equal to 1. We can never use 1. We're going to pick 0.9. So I'm supposed to take, in this case, 0.9 squared minus 4 times 0.9 minus 1. But my calculator is capable of doing this for me. I don't have to do this over and over and over. So if you recall, answer stores the last number that you do. If I take 0.9 and hit equal, now 0.9 is stored in my answer. Recall answer, it's 0.9. Now if I take, instead of putting 0.9, so I don't have to do this over and over, if I take answer and I square it, minus 4 times my answer, minus 1, that will give me the value, which is a negative 3.79. This is a negative 3.79. The advantage of using the calculator that way, when I get to 0.99 and I want to plug that in, instead of saying 0.99 squared minus 4 times 0.99 minus 1, well, instead, this turns out to be negative 3.79, and instead, I just go in there, and all what I have to do is store 0.99 in my answer. And if I go back up, when it recalls this, it just replaced the answer by the last number that I put in, which is a 0.99, and that's a negative 3.9799. A negative 3.799. When I get to the third number, and I would like to plug in, so we said this was negative 3.799. When I put in 0.999 in there and there, That's going to get me a 0.999 squared minus 4 times 0.999 minus 1. Guess what? All what I have to do is take 0.999 and hit equal. It's going to store it in my answer. Done. So if I go answer now, I'll notice 0.999 is there. If I go back once, twice, until I see that equation that I plugged in, all what I have to do is hit enter. It already stored 0.99 right there and right there. This way, I don't have to re-input this. I just copy it. 99799. 3.79. Oops, forgot it. 99799. And let me make sure the other ones were correct. 0.99. Did I copy those right? 3.9799. Okay. Look at that. That was negative 3.979. This was negative 3.99799. And the first one was a 0.99. I think I missed all of those. Oops. 0.99. Go back one and hit enter. 3. Wow. Okay. 0.9 enter. Okay, that's fine. So, notice I picked a 0.9, then I picked a 0.99, and then I picked a 0.999. Now, I'm going to pick problems from the other side if you notice. When I say this is 1.1, let's say that's 1.1. I'm sorry. From the out to the inside. 1.1. This is 1.1. Well, no need to reinvent the wheel. Everything's already in my calculator. All what I have to do, okay. Let me open it again. Let me see if it's still there. If I take 1.1 and store that in my answer and go back, okay, it's not there anymore. I have to input it. So I'm going to input, remember, and my answer now is 1.1, right? So if I take my answer and square it, minus 4 times my answer minus 1, and it's going to give me a negative 4.19. Negative 4.19. If I replace n by 1.01, a lot closer to 1, well, all what I have to do, 1.01, enter, and go back and input that. That is negative 4.0, negative 4.0199. And if I go ahead and in 1.001, even closer, 1.00, oops, 1.001, enter, and if I go back and evaluate, negative 4.00, negative 4.001999. So look at this. Look at this number right here, the closest we got to 1, and look at this number right here. What does that look like? If you round negative 3.99799, or if you round negative 4.00199, what do you think that is? We claim here that this limit right here, this is on page 58. We claim that the y value is approaching a negative 4. Well, not to worry if you didn't get that, because we're going to do it again and again. So let's see if we can get it right this time. Now we're doing the same thing. We're getting close to 0, right? If you look at the middle, the question mark is what you can't plug in. And you try 0 and there you get undefined. So around 0, I'm going to pick points to the left of 0. They picked negative 0.1. and negative 0.01 and negative 0.001. Then they went on the right hand side and they went to 0.1, 0.01, and a lot closer. So here you'll notice that x is approaching 0. That's why we're picking numbers around 0. Now, something I'm going to write once I'm done with this example. Now, what's the hard part? Well, I need to plug this in my calculator. Wherever you see an x, you're going to plug in answer. So this is the y, and that's what we're trying to figure out and fill in those blanks. Here's my calculator. The first value I'm going to play with is a negative 0.1. Make sure to use this negative 0.1, enter. It's stored. Now I want to input this in my calculator. So instead of going in there and saying, well, let's take a square root parentheses negative 0.1 plus 2, go out of the radical, minus square root of 2, right? I forgot to put parentheses. Let me put parentheses in there. Come on, come on, come on. That is the whole top divided by negative 0.1. Instead of doing this work and getting whatever this number is, 0.35808, 0.3580869 or 7. Well, instead of doing this and getting that number, 0.8, 0.3, oh man, 0.38. Okay, I'm stuck on the 8. Let me see what that number is. 0.358, 0.358, 0.87, 0.87. Now when I get to this number, do you see that I have to redo the whole thing? I have to go back in there and I have to reinsert a 0.01 for each of those. Well, instead of that, look at this trick. I take negative 0.1, enter. And when I input this, instead of x, all what I have to do is input an answer. Answer plus 2. Go out of that, minus radical 2 divided by answer. And do you notice I get the same answer? Now when I want to go in and plug in negative 1.01, all what I have to do is take negative 0.01, enter, and now if I go back and hit equal, it'll give me the answer, and there it is. And that turns out to be 0.353, 996. And when I get, when I get to the negative 0.001, go back once, hit equal, there it is. 0.358, 0.353, 0.353, 5976. 5976. Now, do you notice all of these numbers are from the left? So we say the limit as x approaches 0 from the left of the square root of x plus 2 minus radical 2 over x equal, what do you think these values are? Let me put them side by side. 0.358087, 0.353996, 0.3535976. Can we agree at least on the 0.353, at least that much. Let's see what happened when we pick the points to the right of 0, meaning point 1. Point 1 is above 0. Again, point 1, enter, go back once and evaluate, and there it is. It's 0.3492, 0.3492, 411. Alright, how about if I plug in 0.01? There it is. Go back and evaluate. 0.035, 0.35, 113. And if I plug in a 0.001, enter, go back once, evaluate, I'll get 0.35350. So do you see these numbers are above? We say the limit as x approaches 0 from the right of this radical x plus 2 minus radical x over 2 equals, and what did we get? Let me list those for you. I'm looking at to the right, I'm looking at a 0.3492411, 0.353113, 0.3535. Do we agree that this is 0.353 at most? So if these numbers match, and they do match, we say this limit equals 0.353. So you look from the left, you look from the right, and they have to match. If they go back to the previous problem, did you notice these values right here were below 1? So the limit as x approaches 1 from the left of x squared minus 4x minus 1 was, and what did we get here? Do you see we got a negative 3.99799. If you round it, that's roughly a negative 4. And do you notice all of these numbers here are above 1? We say the limit as x approaches 1 of x squared minus 4x minus 1 from the right. And what did we get there? We actually got a 4.19, 4.019, 4.00, negative 4.00199, which is roughly a negative 4. So here, this is going to approach a negative 4. Here, we're going to say this question mark right there is going to be a 0.353. Those are cluttered. Let me make the next one a lot neater, so I really don't have to make all of this messiness. I look here and I'm approaching 2, negative 2. So it would be wise just to put the number in the beginning, and I'm gonna look at the limit as x approaches negative 2 from the left. I'm gonna look at the limit as x approaches negative 2 from the right, above. So let's do this in green. See what we get. And that's these values. I'm going to plug in this number, negative 2.1, negative 2.01, and negative 2.001. If I go to my calculator, if I take this negative 2.1, enter, it started in my calculator. Now I'm going to plug in this function. And let's see how that works. This says parentheses 1 divided by 2. There it is. Oops. Minus 1 divided by parentheses answer plus 2. That's the entire top. Done. Divided by, parentheses, 2 times my answer. That'll take care of it. That's given me negative 2.5. This says it's negative 2.5. Okay, so from the left I have negative 2.5. What if I got a bit closer? What if I take negative 2.01, and if I go back to my answer and evaluate that, that's negative 25. And what if I would go ahead and plug in a negative 2.001, a negative 2.001, I'll get negative 250. So if I'm really working on this, okay, let's do the right. Let's do a 1/2 minus 1 over x plus 2 over 2x again. So from the left, what are we concluding? Negative 2.5, negative 25, negative 250. If you're not sure, pick a number closer. How about negative 2.0001? If I take negative 2.0001, I'm getting negative 2500. Can you guess what this is approaching? It looks like it's approaching negative infinity. How about the one from the right? How about if I pick negative 2 from the right, negative 1.9, negative 1.99, and negative 1.999. So let's take negative 1.9. I'm getting 5/2. How about negative 1.99? I'm getting 25. And how about negative 1.999? $250. Can you guess what's happening from the right? I'm getting 250. So, what do we say here? We say this limit as x approaches negative 2 does not exist. Does not exist. Or simply D and E. What does that mean? If the limit from the left does not equal the limit from the right, the limit does not exist. If the limit from the left, notice those, if you round to the nearest integer, those are the same. If you round to the nearest integer, or, those are the same. 0. Or at least the first 3, if you like. 0.353, they're matching. But here, one side is going negative 250, negative 2500, negative 25,000, and the other side is going 2500, 25,000. So that means the limit doesn't exist. Now, if I look at this graphically, another way of doing this, the next set of problems, we want to find the limit using a graph. Given a graph, number 2, what's the limit as x approaches to? X equal to is right there. So if I look at x equal to, the y value associated with that is negative 4. They want 1. That's negative 2. Negative 1. That seems to be negative 4. And 3 is 0. So let's see. The limit as x approaches 2. Let's talk about 2. If x equal 2, I'm trying to look from the left and from the right. I look at the limit as x approaches 2 from the left. Coming from the left side of 2. So as I get very, very close from the left, y is leveling off next to negative 4. That's good. But that's not enough. I still have to take the limit as x approaches 2 from the right. If I look at 2, there's 2 from the right. Coming from this side, what's the y leveling off next to? It turns out to be a negative 4 as well. If the left and the right match, I say that's a negative 4. Otherwise, I'll say that limit does not exist. Now, if I do the same thing, but I do the same thing for 1. X equal 1 is right there. The limit as x approaches 1 from the left. Coming from the left, this is the left. Doesn't y level off next to -2? If I take the limit as x approaches 2 from the right, well, did I say 2? I meant 1. 1, there is 1, but from the right side, along this path, as I get very, very close to x equal 1, I notice y is also a -2. So that would be a -2 since the limit from the left equals the limit from the right. If the graph is continuous, normally this is very simple to do, not very challenging. How about x approaches -1? -1 is right there. It's that value. If I take the limit as x approaches 1 from the left, well, from the left to the left of 1, because that's to the left of 1, corresponding to this part, y is leveling off next to -4, it seems. And if I take the limit as x approaches -1 from the right, -1, there's -1 from the right hand side. As I get very, very close to -1, the y value is also a -4. So that turns out to be a -4. So by inspection, you could glance at it. You really don't have to do much work. That is, if you look at, for example, 3, you say there's 3. From the left, it's leveling off next to 0. And from the right, it's leveling off next to 0. Therefore, it's 0. But if it's a show, then you actually say 3 from the left is 0. And the limit as x approaches 3 from the right is also 0. And I am going to give you the homework. And your first homework assignment on 1.5 is on page 57. You're going to do 1 through 11 odd.